We continue our lecture on vectors, where we, in the previous video, you've seen the definition and the length and direction of a vector, and now we will talk about Cartesian coordinates, addition, and scalar multiplication. So Cartesian coordinates are the coordinates we're most familiar with. We have a axis here, and we have different, well, we have an x, y, and z axis. Cartesian coordinates is simply expressing a vector in this space with its x, y, and z coordinates. But we can do this a bit more formal as well. So let's say we have our axis here for three-dimensional space, and we have three special vectors. We have the vector here in the x direction, which also I shall call I. I is the vector 1, 0, 0 is the vector in x direction with length 1. Now we have three of these, so we have one in x direction, which we call I, in y direction we call it j, and in z direction we call it k. And so j is equal to 0, 1, 0, and k is equal to 0, 0, 1, and they're all the vectors in their respective direction. So this is the y direction and the z direction, and they all have length equal to 1. Now, if a vector has length 1, we call it a unit vector. Unit vector. So a vector is a unit vector if its length is equal to 1. And if it is a unit vector, sometimes we write, instead of an arrow above the letter, we write a little hat. Now, so if we take a vector in 3D space, let's, for example, take the vector 1, 3, 4. It is 1 in x direction, 3 in y direction, and 4 in z direction. And we can write out this vector as 1 times I plus 3 times j plus 4 times k. And if I were to write this out, this would be 1 times I will be 0, 1, 0, 0 plus 0, 3, 0 plus 0, 0, 4. Not that we've discussed addition and multiplication yet, but they'll become apparent in a minute. And this together is 1, 3, 4. So this is a way of expressing a given vector in its unit vectors I, j, and k. And this can be handy. Well, this is sometimes used in engineering, where it is more common to use this format than that format. Okay, so we now are able to express any vector in terms of our unit vectors. There are also some special vectors. Beside these unit vectors, there is the zero vector, or the null, I should say. Null vector, and we have these in every space, and with space I mean in R2 we have the null vector, which is 0, 0, and in R3 we have the null vector 0, 0, 0, and we write it out as 0 with an arrow above it. It's simply the vector consisting only of zeros. All right, so we can express vectors in Cartesian coordinates now. There are two things left. One is addition and one is scalar multiplication. Now, if I have a vector A, which I can write out as ax, ay, and az, whoops, and we have a vector B, which is bx, by, bz, then we can add them together. A plus B. And if we add them together, this is simply the sum of the x coordinates, bx, ay plus by, and az plus bz, and it becomes a new vector. So for example, if we have the vector 1, 2, 3, and we add to it minus 2, 5, 1, and we add them together, then we get 1 minus 2 is minus 1, 2 plus 5 is 7, and 3 plus 1 is 4. And this is adding two vectors together. We can also multiply a vector with a constant. So if we have the vector 1, 2, 3, we can multiply that by, for example, 3. And multiplying a vector with a constant is the same as multiplying each element with that value. So we get 3 times 1, 3 times 2, 3 times 3, which is equal to 3, 6, 9. In general terms, if we have a scalar k, so some constant value, and we multiply this with our vector ax, ay, az, we get k ax, k ay, and k az. So now we can express a vector in a certain space in its Cartesian coordinates. If we have a two-dimensional space, you only use I and j, by the way. This is just the general form for three-dimensional space, but you can have a two-dimensional space as well. In engineering, we don't go higher than, well, in this notation, we don't go beyond three dimensions. We've seen how to add two vectors together, and we have seen how to multiply a vector by a scalar. In the next video, I will talk about the inner or dot product, and later we will also talk about the cross product, or in Dutch it's known as the outer product. The cross product, we'll go into that next video.